Hi, everyone. Welcome to this introduction to the SPT Metalog Workbook. Before we get started, please note the information at the top. The workbook is licensed to you and everyone under Creative Commons Attribution License. So as long as you provide attribution, you can copy this workbook, make derivative works, use it freely, including for commercial purposes. The workbook contains no macros, no named ranges, and it may be safely copied to other Excel workbooks while retaining the full functionality of this particular spreadsheet. And if you wanted to move this spreadsheet to another workbook safely and have your other workbooks still work, you'd right-click on the three-term metalog tab at the bottom of the sheet here, and click Move or Copy, and then follow the instructions from there. Okay, now let's get started.
In the basic three-term metalog system, I've got an unbounded metalog here. I'm going to call it Asset 1. You can name this whatever you want. Let's say we're going to call it Task 1. Maybe this is the amount of money it costs to do a task. You can name that, and as you name it, it'll show up here in the graph. These are your quantile parameters, 20, 30, and 50. They go exactly through these 3 points. This is the corresponding density function. Okay, here you specify your boundedness. Here you specify, this is alpha, this is your low probability. For example, if I made this 0.05, and you can be sticking your own distributions in here if you want, now you've got a distribution that's slightly different. It associates these 20, 30, and 50 quantiles with the 5, 50, and 95 quantiles instead of the 10, 50, 90. For now, I'll go back to 0.1. All right. Now, over here is a probability. And if you and what this is this is in place that allows you to do simulations here. So if you put into this cell an equals rand function, okay, now you've got every time you press the F9 key, you'll have a different random sample here. Okay, I think I did that right. I'm not going to spend a lot of time trying to demonstrate that, but yeah, there it goes. So every time you press the F9 key, you get a different random sample. So that's how to expand it to do simulation if you wanted to. There also, this thing has built into it a number of things that you could do that are really errors. For example, suppose you didn't enter one of your quantiles. Well, it would say, hey, your input quantiles need to be numeric. So that's what this message box is for. It anticipates any mistakes that you might make. Also, if you put in illegal entries, suppose you put a 40 in here, well, it'd say your input quantiles need to be strictly increasing. You can't have a low quantile that's higher than the median quantile. So that's just an error in inputting information. But you could put in 20, 30, 50 there, and there you go. Okay, oops, sorry. All right, so now there we are for that. Now, suppose you said, look, what I really want here is suppose this is a cost for a task or something, and you see that the unbounded metalog is in fact, I'll put a 15 in here just for illustration purposes. You see that the unbounded metalog is going below 0, and you say, well, I don't want that for a cost. I want it to be a bounded distribution. So you come over here and you pick the SL, that means semi-bounded on the lower end, and you have now a metalog distribution with these same 10, 50, 90 quantiles, but you can specify the lower bound to be anything you want. If you want the lower bound to be -10, and I don't know why you would, but you might. If you did, now you've got a distribution with a lower bound of 10. I'll go back to 0 now for the moment. You can also do a semi-bounded high distribution. And that's now what it's saying here, you need a numeric upper bound. Okay, so let's say you put that in as 100. Okay, now you have a semi-bounded distribution that has an upper bound of 100 and no lower bound. Okay, if you wanted it to have both an upper bound and a lower bound, then of course you'd use the logit metalog distribution. That's the B on this spreadsheet. And now you have a distribution that has an upper bound of 100 and a lower bound of 0, and it still goes through these same 10, 50, 90 quantiles. And of course you can change these so long as you stay within feasibility ranges. So let's go to 25 here. Okay, it's a more skewed distribution. Let's go to 20. It's even a more skewed distribution. Let's go to 17. Now you are outside of the feasible range of the log-metalog distribution. It cannot get that skewed. So what it's telling you with the message there is enter a feasible median between 1907 and 42.83. That's the range of feasibility for the bounded metalog. So let's just, for interest, put in 19.08, 19.08, enter. Okay, well that, there it is. Now, obviously, that's an extremely skewed distribution. That turns out to be about the most skewed distribution that the semi-bounded metalog, or I'm sorry, that the logit metalog is capable of producing. And we could do a similar thing on the high end. I've forgotten what it said. Did it say 47 or something? 42 is the 42.9, it's 42.8. So put that in, 42.8, okay. And there you go. That's the most extreme example on the high end. Okay, still with the honoring the upper and lower bounds. All right, now a lot of times you're not going to just have one metalog distribution you want to deal with, but multiple ones. So this spreadsheet is arranged so that if you drag it down, you will create a new distribution for a task 2, which could be, let's just say hypothetically, that's a semi-bounded lower distribution, which is really a different distribution, semi-bounded lower. And let's say we'll go back to 30. All right. This one doesn't have an upper bound, so you can erase that, but it's not going to use it anyway if you've specified a semi-bounded lower distribution. And now there it is. Now, if you want to view that one, you say, okay, well, I want my display variable is number 2 now instead of number 1. So there's now distribution number 2. If you want to go back and look at distribution number 1, you can just change that to whatever. Okay, so you get that. And then this process can go on and on. So in other words, you could take this and roll it down for as many different distributions as you wanted. You know, there's, now we've got 15 of them, and maybe you have a model that actually has 15 uncertainties in it that you'd like to simulate. Well, you can easily do that, and you can fill it in with whatever names you want here, whatever boundedness, and each one of these is a separate distribution. Then you can view and see what that looks like using this this capability here. If you looked and see what's in this message box here, it's just a formula, and that formula is, let's see, you can see it's a relatively large, complicated looking formula up here, but it's just doing all the if conditions it knows of on your inputs, and it just gives you a message if any of those inputs are not working or are not in usable ranges.